Welcome to your Dive in 5 for Grade 5, Unit 6, Multiplying Decimals. My name is Barbara Knox.
And I'm Daryl Frost.
Before we begin today, we'd like you to pause the video, and on the next slide, you're going to see a task, either on your own or with a team or partner. If you're watching this together, we want you to work through the task. Reflect as you're working about why it's important for students to be able to think flexibly about numbers and how important estimation might be when we multiply decimals. Here we see our progression with best. In 4th grade, when they were looking at values of digits, they were moving one place to the left or right. And in 5th grade, that's going to move from one place to more than one place. They have multiplied multi-digit numbers, so they should be familiar with the open area model and maybe even an algorithm.
Definitely with whole numbers. And I'm also noticing here in 4th grade, they're now performing operations with decimals, adding and subtracting.
Correct. So they've worked not just with modeling decimal numbers, but also with the operations of addition and subtraction. In 5th grade, they move more than one place to the left or right, and they do read, write, and compare decimals all the way to the thousandths place. In 4th grade, it was only to the hundredths place. This is where our focus will be in this unit, but you're also going to bring in that benchmark about multiplying a number by a fraction that is less than or greater than 1 to determine the relative size of the product. That's going to come into play when we're multiplying decimals, because you're going to want to know, if I multiply a decimal times a whole number, do I get a larger or smaller product, right?
Gotcha.
As they're going about patterns. So there are two focuses for this unit. One is multiplying decimal numbers by decimal numbers, using estimation, rounding, and place value. And the other benchmark, which is really a precursor, is going to be multiplying by 1/10 and by 1/100th.
So we're going to begin with the 1/10, multiply by 1/10 and by 1/100th, as to build that conceptual understanding with patterning there.
Yes, and really we're also tying back to that benchmark about moving, how the value of a digit moves or changes as we move one place to the left or right.
And I'm glad you said the decimal point doesn't move, it's the value of the digit changes.
When we use base 10 blocks as models for decimal numbers, we have to create flexible thinkers with our students. We can use any one of those blocks to represent the whole. So on this slide, I'm saying that the flat represents one whole. How do I know that the rod is 1/10, Daryl?
Well, I know that the rod is 1/10 because it takes 10 of those rods to equal one whole. So therefore, if the flat is a whole, each rod must be 1/10. And I may need, as a 5th grader, I may have to have my students build that, like lay those rods on top of that flat to make that connection.
Yes, and as a teacher in that classroom, while they're building, I would want to be creating a class anchor chart. So if I'm using the flat as the whole, here is what my 10th is, and here is what my 100th is.
That'd be a great student-generated anchor chart with decimals in 5th grade classrooms. Yeah.
I might also use the large cube as my whole. And if the large cube is my whole, now what is that rod?
It would be 1/100th, because it takes 100 rods to build that large cube.
Yes. And I would want to add this to my anchor chart. So if the flat is my whole, this is what the other pieces represent. If the large cube is my whole, this is what the other pieces represent. Why wouldn't I, Daryl, want to use the rod as my whole in 5th grade?
Well, in fifth grade, we work with decimals to the thousandths. We're going to be multiplying and getting products to the thousandths, so it makes sense that this will be my core instruction right here. That
Yes.
large cube is going to be a whole.
Within this unit, you will use the flat as your whole when they're first multiplying, for example, 3/10 of 4/10. You might use the flat as a whole because I can make an area model with that flat that I couldn't make if I was using the large cube as my whole.
Exactly.
So when we start this unit, we're going to be working with finding 1/10 and 100th of different numbers. So looking for patterns, if I'm finding a tenth of a whole, I'm going to start with my large cube representing the whole.
Makes
And
sense.
how am I going to find 1/10 of that, Daryl, with a concrete model?
Well, if I know that the large cube is a whole, I'm going to think about my flats because it takes 10 flats to make a whole, and there they are, and then one of those would have a value of 1/10.
Yes, so I have to go back to what was the whole. That's 1 out of 10 parts that made the whole.
Through all of this, it's important to go back, just like with fractions. That's the
Yes.
strong connection
Mhm.
between fractions and decimals. We have to consider what the whole is.
So I know that when I'm multiplying a tenth times a whole, that I'm going to get tenths.
Yes.
So now using a concrete model to find 100th of a tenth, I first have to model the tenth, which you see on the screen. That is 1/10 of a whole, going back to that large cube being my whole. I have to find 100th of that tenth. So what am I going to have to do?
So I need to take that tenth, which is the flat, and break it into 100 pieces, which would be the small cubes. There you go.
So now I want to find 100th.
So one piece, but I have to think about that large cube as a whole. So it takes 1,000 of those small cubes to equal the large cube. So it's got a value of one. There you go, 1,000.
Exactly.
And that kind of thinking is what we want students to be doing as well.
Yes. So Daryl, I created some models so that students could represent their thinking with a representational model.
Okay.
What do you notice and what do you wonder about these models that you see on the slide?
So if I think about a fifth grader, what I would like for my fifth graders to notice is that I see rectangles and I see them decomposed differently. The wondering, if we're thinking about math wonderings here, well, what's the value of each of these? Like if I see that one kind of like blank rectangle, if that's a whole, then the others are decomposed into small, different size pieces. What's the value of them?
And if that large rectangle represents the whole, then I also see tenths, hundredths, and thousands.
Then I would see tenths, hundreds, and thousands.
Exactly.
Yeah.
This model is not on any of the guides, so if you want to grab this model, you can access it at this short URL. Take just a minute to copy down that web address. We've been talking a lot today about looking for patterns. So this is another thing, Daryl, that I might want to put on an anchor chart.
I was just thinking that.
Right.
Yes.
What happens when I multiply a whole times a whole, a tenth times a tenth, and recording what happens each time I make those
That's
multiplications.
huge with this benchmark here that they're seeing patterning and what's happening.
Yes. So here we have, we're going to find one group of one whole, so 1 times 1. I have to know what my whole represents. So here is my whole, and I want one group of that whole.
Which is 1.
So a whole times a whole is going to give me a whole.
And I can see that conceptually. And I think that's important that they do that because they just may say, well, 1 times 1 is 1. Prove it.
Right.
There's a model that
Right.
proves it.
If I'm finding 1/10 of a whole, again, I have to represent my whole in order to be able to find 1/10 of it. I'm going to break it into, Daryl, how many equal parts?
10 equal sized pieces. I have tenths. One of those has a value of 1/10.
So a tenth times a whole is going to give me a
Tenth,
yes.
1/10. Makes sense.
100th of one whole. Again, I want to model my whole first. I need to find 100th of this whole. So in order to do that, I have to break this into 100 equal parts. I find one of those 100 equal parts. And when I multiply 100th times a whole, I get
100th.
Are you starting to see some patterns, Daryl?
Yes, and yes, I'm seeing patterns here with, and I can see an anchor chart being generated as students start this kind of reasoning.
Exactly.
To anchor their thinking.
Now I'm going to model 1/10 of 1/10. I have to first model the tenth.
Okay.
So here is 1/10 of the whole.
Yes.
I'm going to find 1/10 of that piece.
Okay, so I need to break it up into 10 equal sized pieces. But I need to think about the whole.
Yes.
Now I'm really seeing it. The whole it's 100 pieces to make the whole, so that's worth 1/100th.
So 1/10 of 1/10 is
100th.
Yes.
Ah, that
so
makes sense.
Times tenths is going to give me hundredths.
Yep.
1/10 of 100th, I first have to model 100th.
Yes, there it is.
I need to break that 100th into
10 equal sized pieces.
And I want one of those 10 equal sized pieces. Going back to the whole, what does that one piece represent?
It's going to be 1,000th because I have 1,000 of those equal sized pieces and you shaded one of them. So it's worth 1,000.
A tenth of 100th is going to give me 1,000.
Yes. I can see all this on an anchor chart.
Yes. Now I'm going to find 100th of 1/10. So first I'm going to model my tenth.
Yes.
I have to break it into 100 equal pieces, and I want one of those 100 equal pieces.
Which is still going to be 1,000th.
So it doesn't matter if it's a tenth of 100th or 100th of a tenth, I'm still going to get
1,000. And doesn't that connect to the cumulative property?
Yes, it certainly does. It sure does.
I'd want that students to see that.
Yes.
That's the flexibility of properties.
So how is all of this understanding going to help me when now I'm multiplying a decimal number by a decimal number that isn't just tenths and hundredths, 1/10 and 100th?
So now I'm multiplying tenths by tenths.
So I should get, according to my patterns,
I've got to think about what should be some hundredths. I
should get hundredths, right?
Well, if I'm thinking about the large cube as the whole.
What do I have modeled on the screen?
You have tenths here.
How many tenths?
4/10. So I see the 4/10.
Modeled my 4/10, but I'm going to take 3/10 of that 4/10. So what am I going to have to do, Daryl?
You're going to have to break those tenths up into hundreds because I know from my anchor chart that tenths by tenths is giving me hundredths.
Yes. So I break those up, and now I'm going to take 3 out of every 10.
Yes. But that's 12 hundredths.
Yes, because those pieces are in the size of 100ths.
Hundredths.
So I have 12 hundredths. I could also regroup and show that I have 1/10 of the whole and 2 hundredths of the whole. So when I look at the place value where those digits are placed, I have 12 hundredths or 1/10 and 2 hundredths.
Yes. And it'll be very important for students to use base 10 blocks and representational models and not just thinking about this as some sort of algorithm to have that deep-rooted conceptual understanding.
So here we have the same thing with a representational model. Again, I'm going to model my 4/10. So here are my 4/10 of the whole, and I have to find 3/10 of those 4/10. Again, I'm going to have to break these up into smaller parts in order to be able to do that.
Because I know from my patterning that the product is going to be in hundredths.
So I break it up into 100th-sized pieces. Now I can find 3/10 of every tenth. So there's 3/10 of each of the 4/10. If I slide those together, I have my 12/10. and I can also see
Yeah.
the one, I'm sorry, 1200ths, and I can
1200s,
also
yeah.
see the 1/10 and the 200ths.
Absolutely. Yes. And also seeing that, oh, I'm taking a part of a part. So through it reasoning, I would want students to start thinking about, well, if I'm taking a part of a part, my product is going to be smaller.
Yeah, we're going to see that on the next slide, Daryl.
Okay.
So some of the misconceptions that can occur with multiplying decimals. Thinking that the product is always larger when you multiply, right?
Oh, well, that's what I just said just a moment ago.
Yes.
Like I'm taking a part of a part. So
It should be a smaller
it should be a
piece.
smaller piece. The product is going to be smaller than both factors.
I
Yeah.
also want to have them visualize both of those factors and visualize the product. So if I visualize what 3/10 looks like, here it is. If I visualize what 4/10 looks like, you see it in blue. Think in your mind how big those pieces are, the 3/10 and the 4/10. And now we're going to look at the product. We know that the product was 1200ths. So here are my 1200ths. And what do you notice about the size of the 1200ths?
It's way smaller than either factor, either the
Exactly.
3/10 or the, okay, I see it there. That would
Exactly.
be really important for kids.
It is very important for students to see that the size of the product is smaller than the size of the two factors.
Yes.
Going back to our initial task that you did at the very beginning, we're going to do some estimation and using estimation to help us place decimal points. In red, you see the product as if the decimals weren't there. So as if I'm multiplying 6 times 348, the product is 2088. I can do that with any type of algorithm. I can do it with an open area model. I can do it with a standard algorithm. So if they know how to multiply whole numbers, they can multiply decimals. Just ignore the decimal for a minute, find the product, and then talk about where that decimal point would go. Daryl, looking at the first one, where would you place the decimal point and why?
So in 6 times 3 and 4800ths?
Yes.
So I think this is where the estimation and the reasoning comes into play and not treating the decimal point as a procedure,
Correct.
but reasoning. So if I did exactly what you said as a fifth grader and I multiplied and I got 2088, if I'm thinking about the 3 and 4800ths, I see 6 times 3 is 18.
Correct.
Okay. And then if I even though 3 and 4800ths is not quite, is less than half going to 4, but if I thought 6 times 4 is 24, I know my answer is somewhere between 18 and 24. Well, 20 is what makes sense. So I would place the decimal point confidently after the 0.
Yes. It doesn't make sense that the product would be 2 and 8800ths because no. 2 is way less than 18. And yes. It doesn't make sense for the product to be 208 and 8/10.
No.
That's way too much.
Yes.
So using estimation and going back to the patterning that we did, we know that we're multiplying a whole number times hundredths. So we should have hundredths in our answer.
Exactly. Exactly.
What about the next one, Daryl? Multiplying 3/10 of 6/10.
Well, I'm visualizing that anchor chart. I'm multiplying tenths by tenths, and I've had lots of experiences. I know my product has to be hundredths, and so it's 1800ths.
Correct. When I look at 4/10 of 13 and 7/100ths, I know that it's going to be a little bit less than half of 13. And I know that half of 10 is about 5, so it's going to be a little bit more than 5. So I would confidently place my decimal point between the 5 and the first two.
Yes, 5 and 228 thousandths.
Right. Talk to me about the last one, Daryl.
Okay, so I have tenths by tenths, so I know I've got hundredths in my answer. So I could think about it like that, or I could think about just doing some, think about whole numbers and a basic fact. 5 and 2/10 is close to 5. So I could think of it as 5 times 7 is 35, okay? Mm-hmm. Or if I rounded 5 and 2/10 to 5 and 7 and 9/10 to 8, 5 times 8 is 40. So I know my answer is going
close to 40.
Close to 40, somewhere in there.
So what makes sense?
41, I'd put the decimal point after the 1, because then I have 41 and 800ths.
So if I take another way to think about it, if I take that 5 and 7 and forget everything else, 5 times 7 is 35. I think you talked about that.
Yeah.
What if I turn the 5 into the next higher digit? So I
Oh.
know that 5 is between 5 and 6. So I make this 6 and make this 8. 6 times 8 is 48. I know that my product should be somewhere between 35 and 48.
Okay, I never thought, yeah, that makes sense too. Okay,
Okay.
very good.
Again, moving between the islands, we would definitely start with the concrete. We're going to use the base 10 blocks when we're multiplying decimal numbers. Representational thinking, you have some tools, both quick pictures and the representational model that I shared with you.
And the
And
grids.
yes, and abstract thinking, we are going to use just our decimal notation using the patterns to figure out where those decimal points go. But we want to go back and forth between these islands and create those bridges, right? So I want to be able to model 3/10 of 7/10 on my model, and I want to be able to model it with the concrete tools. When I get to factors like 4 and 7/10 and 6 and 3/10, it's not as easy to model with the tools. By then, we want them to be able to apply that abstract thinking, the patterns that we've been talking about, the estimation, in order to be able to find their products.
Yes.
Thank you for joining us today for this session of Math Dive in About 5.
Bye.
See you next time.